Okay, let's unpack this. Imagine a world, right, where the actual silicon chips, the ones powering our AI future, they're becoming, well, battlegrounds.
Yeah.
Today, we're doing a deep dive into a really monumental shift, something that's reshaping global tech, geopolitics, everything.
Mm-hmm.
Our core topic is China's recent ban on Nvidia AI chips. It's a move with some pretty significant ripple effects.
Definitely.
We've gathered insights from official reports, financial analyses, industry statements, basically trying to give you a clear, concise shortcut to understanding this really complex, fast-moving situation.
And hopefully by the end of this, you'll get a more nuanced view, right? Not just the headline.
Exactly. The why, the long-term stuff, and how it impacts the future of AI for, well, for everyone.
And what's truly fascinating here, I think, is that this isn't just, another trade spat. It feels different.
How so?
It feels like a strategic pivot. Like we're actually watching the formal solidification of two pretty distinct technological ecosystems, almost like a digital iron curtain forming.
Wow. Okay. Digital Iron Curtain. That's a strong image.
Well, yeah. And our sources for this dive, they cover quite a range. We're looking at new regulations, financial reports, technical comparisons of the chips themselves, and these broader geopolitical analyses, trying to piece together the whole picture for you.
Okay, let's start with the ban itself then. What exactly did China do? Because this wasn't just guidance, was it?
No, not at all. This is a formal directive, came straight from China's Cyberspace Administration, the CCC,
Right.
and they've explicitly told major domestic tech firms, think ByteDance, Alibaba, those guys, to completely stop buying NVIDIA's AI chips. Full stop.
And they named a specific chip.
They did. The RTX Pro 6000D. And here's where it gets really interesting, like you said.
Yeah.
That specific chip, the 6000D, it was meticulously designed by NVIDIA to comply with the existing U.S. export controls.
Ah, okay. So it wasn't even one of the top-tier restricted ones.
Exactly. It was supposed to be the allowed chip. So by banning even that one, Beijing is sending a really clear message, basically. Even the compliant chips, the ones allowed by the U.S., are no longer welcome here. This is formal, it's enforceable, they're even canceling existing orders for it. It's a point of no return, sort of.
Okay, wow. So how did the market react? NVIDIA's stock must have taken a hit?
You'd think so, right?
Yeah.
But actually, the immediate reaction was, well, fairly muted.
Really?
Yeah, NVIDIA shares, NVDA, saw maybe a 1-2% dip,
Yeah.
which is just that, the sophisticated investors, they'd pretty much already priced in this kind of geopolitical risk.
They saw it coming.
Seems like it. And if you look at the actual financial exposure, China was big for NVIDIA, no doubt. Over 21% of their revenue back in fiscal 23, about $5.8 billion.
That's significant.
Huge. But by fiscal 25, that share had already shrunk to just over 13%. Now, the total dollar amount actually went up to $17 billion because NVIDIA's overall business exploded, but the percentage from China was already declining.
So the writing was maybe on the wall, even before this formal ban.
Kind of looks that way. Prior U.S. constraints were already biting. And NVIDIA's CEO, Jensen Huang, his response was interesting. Expressed disappointment, sure, but he framed it as part of these larger agendas between the U.S. and China.
Diplomatic.
Very. And crucially, NVIDIA had already told financial analysts, basically, don't include China in your long-term forecasts.
Whoa. Okay, so they were actively preparing for a decoupling.
Seems very much like it. It just underscores how even these massive global tech giants are being forced to navigate or sometimes just abandon huge markets because of geopolitics, not just pure economics.
Right. It's a different ballgame now. So NVIDIA was bracing for it.
Yeah.
But why this specific move from Beijing, and why now? What's the deeper strategic thinking here? Beyond just, wanting self-reliance.
Yeah, that's the million-dollar question, isn't it? Look, the big picture goal for Beijing has long been technological sovereignty. They want an autonomously controllable domestic semiconductor industry. That's been clear for years. The U.S. export controls, though, they created huge uncertainty for Chinese companies. Suddenly, your supply chain for essential AI chips is vulnerable, dependent on decisions made in Washington.
Not a comfortable position.
Not at all. So this ban, it acts as a really powerful internal pull mechanism. It essentially forces Chinese companies to commit to domestic alternatives. Like one exec reportedly said, the message is loud and clear. All hands on deck for the domestic system.
Makes sense. But you said there were other drivers converging now.
Absolutely. It wasn't just the long-term goal. First, there's this newfound confidence, maybe strategically amplified, but confidence nonetheless in their own domestic chips.
Ah, so they think their stuff is ready.
Well, the regulators apparently do. This ban didn't happen in a vacuum. They systematically assessed chips from Huawei, Cambricon, Alibaba,
It's
Baidu.
local players.
Exactly. And their official conclusion, which provided the political cover, was that these homegrown AI processors were now comparable to or exceeding the performance of the Nvidia chips still allowed under U.S. export controls.
Okay, so they felt they had viable alternatives in place. That's key.
Very key. Then you can't ignore the element of, well, direct retaliation.
Tit for tat in the tech war.
Pretty much. It's a clear, symmetrical response to years of the U.S. tightening the screws on exports. And it's happening alongside other Chinese moves, like anti-dumping investigations, restrictions on exporting critical minerals like gallium and germanium.
Right, those minerals essential for chips.
Exactly. And then there's one more lever they're pulling, antitrust.
Oh, against Nvidia.
Yep. China's market regulator, SAMR, accused Nvidia of violating anti-monopoly laws related to their Mellanox acquisition back in 2020.
Adding legal and financial pressure, too.
Precisely. It's another tool in the state's toolkit. So you put it all together, it's a really sophisticated, multi-pronged strategy. Nurture your domestic options, conduct an assessment to say they're good enough, then mandate their adoption using regulations, retaliation, and legal pressure.
Wow. It really is like a textbook execution of strategic industrial policy.
It kind of is. A blueprint for how a state can try to drive innovation and reshape an industry. It really highlights how tech policy and national strategy are just completely intertwined now.
Yeah, inseparable.
Uh.
It offers a fascinating glimpse into that bigger strategic game. And of course, central to that whole play are China's own domestic chips. So who are the main players stepping into this gap left by Nvidia? And how good are their alternatives, really?
Okay, well, the name you hear most, the one clearly at the core of China's strategy, is Huawei, through their Silicon division.
Right, the designated national champion, essentially.
Pretty much. They have this full-stack ambition aiming to be a complete alternative to the whole NVIDIA ecosystem, hardware, and software. Their main hardware offering is the Ascend series of AI accelerators.
Like the Ascend 910B, I've seen that mentioned.
Exactly. That's positioned as the main alternative to NVIDIA's older, restricted A100 chip. And the performance claims from Huawei and some independent tests are actually quite strong, anywhere from 80% to maybe 120% of the A100's efficiency, specifically for training large language models.
Okay, that's comparable, at least on paper, for that specific task.
Yeah. And they're working on newer ones, the 910C, 910D, presumably aiming higher up the performance ladder. Now, the big challenge for them is manufacturing, right?
Because of the U.S. sanctions, they can't use TSMC's latest tech.
Exactly. They're largely reliant on SMAC, China's top foundry, using maybe their 7-nanometer process, which is, good, very capable, but it's maybe a generation or two behind the absolute cutting edge that NVIDIA gets from TSMC.
So how are they claiming such high performance?
Through clever design, architectural enhancements, finding efficiencies elsewhere, and also innovative system-level designs like this Cloud Matrix 384 supernode they talk about, which connects lots of chips together efficiently.
Making the whole system perform better, even if individual chips aren't bleeding edge.
That seems to be the strategy. And they are ramping up production like crazy. Forecasts suggest they might ship over 800,000 of these Ascend units just this year.
800,000, that's a serious number, especially with manufacturing limits. But like you said, hardware's only half the story, isn't it? What about the software? NVIDIA's big advantage is CUA.
Absolutely critical point. The software battle might be even tougher than the hardware one. CUA is this massive, deeply entrenched ecosystem, decades of development, tools, libraries, developer familiarity. It's a huge moat.
So what's Huawei's answer?
It's called Canon, Compute Architecture for Neural Networks. And strategically, they've made it open source.
Trying to build a community around it fast.
Exactly. Foster a domestic developer base. Now, everyone acknowledges Canon is less mature, probably more complex to work with right now compared to CUA.
But the ban changes everything.
Right. Suddenly, there's this massive state-mandated incentive to adopt Canon out of sheer necessity. If you want to use the leading domestic hardware, you need to learn Canon.
Forced adoption, essentially. But it's not just Huawei, right? You mentioned others.
Definitely not just Huawei. The big Chinese cloud companies, the hyperscalers, they have their own in-house silicon programs too, mostly focused on ASICs.
Basics, application-specific integrated circuits, chips designed for one job.
Exactly. Often more efficient for specific tasks than general-purpose GPUs. So Alibaba, through their T-Head division, has chips like the Hangguang 800, mostly for inference running trained models, and the Yishan 710 server chip. They use them internally in their cloud, but they also just landed a contract with China Unicom.
Interesting. And Baidu?
Baidu has its Kunlun series. The Kunlun 2 chip, also 7 millimeters, powers a lot of their core services, including their big Ernie AI model.
Okay.
A key thing about Baidu's chips, though, is they've apparently focused on maintaining better compatibility with CUD.
Oh, that's clever. Makes it easier for developers to switch.
Potentially, yeah,
Yeah.
lowering those switching costs, and that might be why they also won a contract, this time from China Mobile.
So different strategies even within the domestic players. What about Tencent?
Tencent's also in the game with custom silicon. Chips like Xixiao for inference, Canghai for video stuff, Shanling for networking, mostly for their own massive internal needs like WeChat and Tencent Cloud.
Right. And there are others, smaller players, like Biren, Cambricon.
Yeah, there's a broader ecosystem. Biren Technology had a powerful GPU, the BR100, but then they got hit by U.S. sanctions, added to the entity list.
Ah, so they lost access to TSMC manufacturing.
Yep, forced them to downgrade their products. It shows the fragility, the dependence on manufacturing access is still a huge vulnerability for many of these players, except perhaps Huawei's MIC to some extent.
Okay, so if we compare the specs directly, say that Huawei Ascend 910B versus an Nvidia chip that was allowed, like the H20.
Right, looking at the numbers, the Ascend 910B is often cited around 400 TFL OPS, that's tera floating point operations per second, a raw compute measure, and it typically has 64 gigabytes of HBM2E memory.
Okay, and the Nvidia H20.
The H20, designed specifically for China under the previous rules, is estimated around maybe 296 TFL OPS, so less raw compute on paper, but it has 96 gigabytes of the newer, faster HBM3 memory.
Ah, so more memory and faster memory bandwidth. That matters a lot for big AI models, right?
Hugely important. Feeding the beast, getting data in and out quickly is often the bottleneck, so it shows there are trade-offs. Raw full PS on everything, memory tech, interconnects, software. It's complex.
So it's not just one big competitor like Huawei replacing Nvidia. It's this whole messy emerging ecosystem.
Exactly. With different players, different strategies. You've got the state-backed proprietary approach like Huawei can, trying to build a whole new stack. Then more pragmatic, maybe CUDA-friendlier approaches from others like Baidu. Real strategic tension there.
That's a really critical point. A whole ecosystem, not just a single rival. And this split, this bifurcation, it's not just about supply chains anymore, is it? You mentioned it's actually reshaping the architecture of AI itself. How is that happening?
Yeah, it's fascinating. Think about the two main phases of AI training and inference.
Training the models versus using the trained models.
Exactly. For training these huge, complex foundation models, NVIDIA's GPUs and CEA are still pretty much king. Their flexibility, their programmability is vital when the field is evolving so fast, when you're experimenting constantly.
Right.
But for inference, taking that trained model and using it millions of times a day for predictions, translations, whatever, that's where ASICs often shine.
Because they're custom built for that one repetitive task.
Precisely. They can be way more efficient. Better performance per watt, lower total cost of ownership, especially at scale. Think Google's TPUs, Amazon's Inferentia chips. They're mostly inference-focused ASICs.
Okay, so GPUs for flexible training, ASICs for efficient inference. How does geopolitics plug into that?
Well, geopolitics is acting like an architectural catalyst here. These U.S. export controls and now China's ban are forcing a divergence based on that very distinction. The U.S.-led ecosystem, it still has unfettered access to NVIDIA's most powerful GPUs. So they can keep scaling up these massive, incredibly complex, maybe even somewhat inefficient general-purpose models. Think of it like a rainforest environment, just abundant compute resources. Throw more GPUs at the problem.
Yeah, the rainforest model. What about China?
China's AI ecosystem is now operating in what you could call a compute-constrained environment.
Right.
They're cut off from the absolute top-tier general-purpose GPUs for training at scale.
Right.
So what does that incentivize? Massive innovation and efficiency, both hardware and software. It pushes them faster towards custom ASICs for inference, where they can design their own efficient chips, but maybe more profoundly.
Yeah.
It forces their AI research to focus intensely on algorithmic efficiency. How do we get more intelligence, more capability out of less raw compute power?
Squeezing more out of every flop.
Exactly. Techniques like model quantization, using lower precision numbers, or developing sparse architectures, models that are efficient because they have fewer connections, these become much more critical. It's more like a desert environment. Resources are scarce, so you have to be incredibly efficient and clever to thrive.
Wow. Rainforest versus desert. That's a powerful analogy. So it's not just a trade war affecting companies. It's fundamentally altering the types of AI that might get developed in different regions.
That's what it looks like, yeah. Changing the economic and technical incentives driving the research itself, we could see genuinely different evolutionary paths for AI globally.
That is, yeah, that's a profound thought. So zooming out again, as these two digital iron curtains seem to be solidifying, what's the bigger strategic outlook? What does this mean for the global AI market long term?
Well, it strongly suggests we're heading towards these two increasingly separate, non-interoperable tech ecosystems. One primarily influenced by U.S. technology and policy, the other by China's.
The standards war you mentioned earlier.
Exactly. Nvidia CUDA on one side, maybe Huawei Kirin eventually dominant on the other. And that means software, applications, even developer skills could become specialized, making it harder and harder to operate across that divide.
Okay. And in that kind of world, controlling the key bottlenecks becomes even more critical, right?
Absolutely crucial. And we see this playing out with certain choke point players. The prime example is ASML.
The Dutch company making the lithography machines.
The only company making the most advanced EUV lithography machines, essential for chips under 7 mm, maybe even 5 mm and below. They are a massive bottleneck.
And the U.S. has pressured the Netherlands to restrict their sales to China.
Heavily, not just the latest EUV machines, but even some of the slightly older DUV deep ultraviolet machines, too. This puts ASML and the Dutch government in a really tough spot between major trading partners.
A geopolitical squeeze.
Definitely. And this isn't just hitting Nvidia. The ripple effects are sector-wide. AMD, for instance, reportedly took an $800 million hit because shifting U.S. rules impacted their own China-specific AI chip, the MI308.
Wow, $800 million.
Yeah. And Intel's downscaled Gaudi accelerators, also designed for the China market, also potentially vulnerable. So it's a challenge for pretty much any Western company trying to sell advanced AI chips in China now.
So, looking forward, what are the big unanswered questions this raises?
Oh, plenty. First, will China's state-driven self-reliance push actually succeed in creating a globally competitive AI ecosystem? Or will being cut off from the absolute cutting-edge tools and maybe less direct global competition mean they always lag slightly behind? It's a huge question.
Yeah.
Then how will the West be affected by losing access to the Chinese market? That's not just lost revenue, it's losing access to vast data sets, unique use cases, a different innovation environment. Does that slow down Western innovation in some way?
What about other countries?
Right. Will we see a non-aligned bloc emerge? Countries that try not to choose sides, that want access to technology from both the U.S. and Chinese stacks. How does that work?
Complex dynamics.
Very. And maybe the biggest paradox here, the U.S. policy was intended to slow China down, right? Contain its AI progress.
That was the goal, yeah.
But has it actually inadvertently accelerated China's push for true self-sufficiency? By cutting off access, did it just create this massive incubator for Huawei and the others, forcing them to develop capabilities they might not have prioritized otherwise?
The law of unintended consequences.
Could be. This containment strategy might, in the long run, create a much more formidable, truly independent strategic rival, one that's completely severed its dependency and built its own parallel system from the ground up.
A systemic competitor, not just a market competitor.
Exactly. It just shows how these big geopolitical decisions can have these really profound, unforeseen long-term consequences. It's not just about company profits, it's reshaping the whole trajectory of global tech power.
So as we see these two digital iron curtains going up, it's really not just about silicon and software anymore. It's about two fundamentally different visions for AI's future, isn't it? Each being pushed forward under vastly different pressures, different incentives.
Absolutely. And it raises this really important, maybe unsettling question for all of us to think about. In a world split between the rainforest of abundant, maybe less efficient compute and the desert of forced efficiency and algorithmic cleverness, which environment ultimately is going to produce the most groundbreaking, maybe the most surprising AI innovations in the long run?
Yeah, something to definitely mull over, don't you think? We hope this deep dive has given you a clearer picture, or at least some frameworks for thinking about this really pivotal moment in global tech and geopolitics. Keep learning, keep questioning, and we'll keep unpacking these complex topics for you.